Hello viewers, this is a video demonstration of a water pump control system developed by me. Some of the salient features of this system are as follows. Firstly, it has a real-time clock which is keeping track of the time, and the user can individually program 6 start and stop cycles for the pump. Each of these 6 start and stop cycles can be individually enabled and disabled. The system has a non-contact passive probe for level sensing. This means there are no metal electrodes which are exposed to the water, and there will be no problem of corrosion of these electrodes, which one usually observes with traditional metal electrodes used for water sensing. Traditionally, water level sensing is done using conductivity of water, which leads to corrosion of the electrodes over a period of time, as there is a very small DC current that causes electrodes to corrode when they are present in water. There are no moving parts or switches for the level sensing, and the system will work trouble-free for many years due to this. Also, our sensor is truly an analog sensor, which measures water level throughout its length rather than in 3 or 4 discrete steps, which is traditionally used on other systems. However, for the ease of readout, we show water level as 10 discrete levels. Other systems using conventional electrodes will show water levels in 2 or 3 levels only. Thirdly, our system has a 4-line LCD display giving details of water level in both the sump tank and on the roof tank, displaying the pump status, the current date and the time. Also, there are 4 tactile switches which are used for configuring the alarms, the start and the stop time, and for system calibration of the electrodes. Lastly, there's a hysteresis loop in the system which prevents the pump from turning on or off in quick succession when the water tanks are nearly empty or are nearly full. What I have conventionally seen is that the water level is sensed using an electrode at the top, and as the water level fluctuates in the overhead or in the sump tank, the pump is turned on and off in a very quick succession. This leads to the relay contacts or the contactor contacts getting welded together, and that shortens the life of both the contactor or the relay and also the pump motor, as it induces stress on the pump bearings. Our system will not have that problem, as the motor will be turned on and off only after an interval of 1 minute. So the hunting problem will not be there, which is usually observed. So continuing with the demonstration, right now the system is in mode 1, where one programs the start and the stop time for the pump and individually enables or disables the cycle. So we have the start time on the first part of the display and the stop time on the second line of the display. We have this third option of enabling or disabling this particular start stop cycle by toggling between yes and no. So continuing with the demonstration, right now the time is 15 hours and 9 minutes and 51 seconds. As the tank levels are empty, both the roof and the sump tank, the pump will not turn on, even though the clock has elapsed and the pump should turn on. This is to prevent the pump from dry running. Once the level in the sump tank is more than empty, the pump should come on, and it should stay on as long as the top tank or the roof tank is not full. So this is our level sensor, and as you can see right now, the sump tank water level is empty, and as I will dip this sensor into the water, you can see the level of the sump tank is going to progressively rise. As I'll keep on immersing my probe in the water, the sensor probe, the level keeps on going up. And now the roof tank is empty and the sump tank has some water level. So my pump should come on. The pump is indicated by this yellow LED lamp, and also the status is visible on the LCD. So the system will wait for the water level to stabilize in the sump tank. This was for the hysteresis loop which was there. So very shortly the pump will turn on. And see, the pump status has turned to on. The LED indicator is also on, which is indicating that the pump is running now. So the pump is now trying to fill water in the top tank. As the water level keeps on rising on the top tank, the level will keep changing for it as well. Now I'm dipping the top roof tank electrode in the water. So the water level is going up. So as long as the top tank doesn't get filled with water, the pump should remain on. See, right now the top tank is full, so the pump will turn itself off. Pump goes off, the LED goes off. Calibrating this system is fairly simple. Calibration of the sensors. You press the menu button and go through the menu modes, and the menu modes will describe you what is the procedure for calibrating the sensors. When you get to mode 9, you can actually calibrate the roof sensor. This is showing you the level in the discrete, not in the discrete but in the continuous form. So as I withdraw my electrode from the water, this level should come down, which you can see is coming down. And by pressing the enter button, we can save these values for calibrating the sensor. It's a fairly simple job for calibrating the sensor compared to the other systems. So as one withdraw the probes completely from the water, as the probe dries out, this level will stabilize. And will be used for calibrating the sensor probe. Thank you for watching this video.